This first video is on how to write the inverse function when the function is linear. The next two videos will be how to find the inverse function of a radical, and finally how to find the inverse function of a rational or inverse function. So the first step, recognizing that we have an output and an input. G of x is equal to y, y is equal to g of x. That's our output, x is our input. We want to exchange input for output. Our domain will become our range, and our range will become our domain. So we exchange x for y. We can also rewrite this giving each of the terms their own denominator, and it simplifies to this. However, for this purpose, rewriting for the inverse function, we'll keep it in this form. So we'll start here. Let's identify first the order of operations on y so that we can reverse that order with the opposite operations to get everything over to the other side with our new input. So recognize that this in order is y is multiplied by a -7. We subtract 10, and then we divide by 5. The reverse order, the opposite operations, would be to multiply by 5, add 10, and then divide by a -7. So let's do that. We'll multiply both sides by 5. And then we'll add 10 to both sides. And then we'll divide both sides by a -7. And we're left with our output y. Rewriting our inverse function is in function notation gives us inverse g of x equals the expression. Here's the original g of x equals this expression. Now let's talk about negatives for a moment, because I know that some of you are rewriting your expressions, trying to simplify. And here's what I want to talk about in terms of simplification. You can move this negative sign to the outside of the ratio. Notice how the negative is being moved to the outside of the entire ratio. If you do that, it could be confusing because some might want to put that in the numerator or the denominator. I recommend leaving it in either. This is okay. This can be confusing. If you want to put the negative in the numerator's place, remember that it's the entire numerator, both terms, that need to get this -1 distributed. It can't just be one or the other. The fraction bar is a grouping symbol, so you need to treat both the numerator and the denominator as a group. So again, if you decide to turn your denominator into a positive and move the negative to the numerator, then you need to distribute that -1 to both terms inside the numerator. Okay, how do we know that the inverse function is correct? Can we test it graphically compared to the original function? Let's move to Desmos and see if we can do that with the line y equals x. So here we are in Desmos, and I've graphed the line of reflection y equals x, and we want to know if g of x and its inverse are reflections of each other. They should be. If they're not, if the inverse g of x that I've come up with is not correct, we won't see a reflection across the line y equals x. Here we are in Desmos. I've graphed y equals x, which will be the line of reflection for both our function and its inverse, if it's accurate. And graphing the inverse, I see that the green line, the inverse, is a reflection of the function, the blue line. This is your opportunity to show graphically that these are inverses of each other. The work we did earlier on paper that is showing that these are inverses algebraically. And the learning target requires you to do both.